Yasmin?
Yeah, Santosh?
Yeah. In that case, Professor Dirk Jansen, the floor is yours.
Okay, thank you very much, Santosh. Welcome to all of you on this first meeting of the Open Science Community. As Santosh says, my name is Dirk Jansen. I'm a Dean of the Faculty of Civil Engineering and Geosciences, but I'm also in the steering board of the Open Science program in TU Delft. My main role there is to be a bit of a linking pin between researchers and the supporters of the Open Science Initiative. Well, that sounds great, but really the work is done by people like yourself who are actually in the field, who are actually practicing open science. And I'm very happy to see that you're organizing yourself, that we do have this open science community now also in Delft. And you're probably all aware that we have quite a forward-looking board at this university who fully embraces the ideas behind open science, although still critical in relation to a lot of aspects, and has the board has supported that by giving quite a large budget to the development of various aspects of open science. We do have an open science strategic plan, and that's about open access, which is the aspect that most people associate with open science, but it's much more. It's also open education, open publishing, and open publishing platform at TU Delft for books. It's about data, of course, not just open data, but fair data. Not always they can be open, but at least you can aim for them being findable, etc., etc. And not only data, also software comes under that realm. Apart from those columns, we talk about reward and recognition. It's great to demand from people to publish in open science journals. At the same time, we all want as young researchers to increase our impact and science citation scores. So it's also up to the community to do more than just look at citation scores, and also reward the fact that you're trying to share your research with a community in a different way than maybe traditionally was done in the traditional journals. So that's a whole second second way of looking at all those columns. It's something which comes across the open education, the access to publishing, etc., etc. The same holds for all kinds of legal aspects. We talk about fruitful collaboration with third parties in that bar, but that all has to do with the fact if you want to cooperate with industrial partners, government parties, you need agreements about IP and how long to keep things confidential, and we need frameworks for that. So that's being worked on. And then finally, you possibly need new skills if it comes to archiving data and to working with open science community to make the distinction between high quality, low quality, etc., etc. So the columns working on specific aspects, there are layers working on the more integrating aspects, but that's all support, and we have wonderful support staff. We have a whole group of people governed from our library, but also working in other parts of the organization to support you, because it's really about the people who do it. And I know the data stewards in the various faculties have played a key role in starting a lot of data and science and open science initiatives. But it's great to see that there's now a lot of grassroots activity of people who support this movement and who are coming up with their own initiatives and who are now combining themselves in this open science community. So with that notion, the fact that you're organizing yourself, I would like to say that I'm very happy to see that, and I think Rob Mudde from the board of our university is also part of this meeting, and I think that's a sign of support. I think that's all I'd like to say. It's more about content this afternoon, so I would like to thank you very much for participating. It's great to see participants. I would like to wish you a very good afternoon, and I would like to announce the first speaker, and that's going to be Natalia Romero from the Faculty of Industrial Design Engineering, and she will be speaking about sharing and publishing of thick data. And what an intriguing title that is. Natalia, the floor is yours.
Thank you. Let me then share my screen, right? Let's see if this works. Yes. So, do you get to see my screen?
Yeah.
Yeah, perfect. Okay, what do you get to see now? I maybe it's no, I did it wrong.
No, we can see the sharing thick data first slide.
Okay, perfect then. Yes. So thank you for inviting me for to this important first symposium of the Open Science group in TU Delft. Well, I'm Natalia Romero. I work as an associate professor at the industrial design faculty in the Department of Human-Centered Design. And what I would like to share these in the next 10 minutes is my experiences sharing and publishing thick data. Let me start with briefly telling you what do I do in my research and how do I get into thick data. So I'm interested in designing data interactions, personal data interactions, where people can learn their own behavior and then take ownership of the decisions they make about their own behavior regarding health or regarding sustainability, for example. And in order to do this research, I'm looking at the knowledge gap that exists between the experts telling us what we should do, for example, in the area of healthcare, to manage our conditions, maybe a chronic disease. They tell us to take certain medicines, to do certain exercises, and they define a number of goals for us in our daily life. Well, on the other side, there is knowledge to understand what is exactly the goals that we have in our lives, which is definitely not taking medicines and doing certain rigorous exercises, but maybe to have a walk with our loved ones or to be able to spend some time relaxing. And here, this is my motivation to understand how actually getting to understand better the values and the preferences of people in their daily life could help us to align these goals from the experts with the goals that we have on our daily lives in order to achieve a better quality of life. On the other hand, this is interesting, this investigation, because particularly in the area of healthcare, the systems are experiencing a large demands of patients and people that needs a healthcare system, yet there is not enough resources for this. So there is also a need to shift a bit the responsibilities and get people with more ownership of their own conditions. So this type of research helps into this. And on the other hand, there is a lot of trends into participation from society, citizen science, where also we want people to empower them in better understanding of their surroundings, so we can develop innovations that are more effective and more close to the people itself. So all this is my motivation to study the interactions with personal data. And then why for me thick data is an important approach to then do my research, and is, well, from our Faculty of Design. Of course, we're interested in understanding what people are actually doing in their daily life, right? And that's what big data give us a lot of information about. But beyond what people are doing, we are more interested in the why. So what are the values behind? What are the preferences? What are the decisions, or why people are taking certain decisions regarding their behaviors? So this is where thick data comes in play. So we gather insights from more depth stories and observations, definitely in a smaller scale than big data, but really helps us to depth in insights rather than to get large N numbers. This is my definition and the way I'm looking at thick data, and why the importance for me as an approach to do my research. And well, there are several ways to gather thick data, and just to give you an example and an idea of what what actually means. Thick data is collected by contextual interviews, where you do it in longitudinal studies, so you follow someone for a period of time, like ethnography studies. You develop diaries where people can actually annotate things they're interested in on a longer term. We also, you make use of kind of daily surveys or samples to get to understand some changes in their experiences or emotions regarding certain applications. So these are some examples of the tools I've been developing to capture these thick data on. And the main characteristic is these tools are really in the context of people's lives, and then they're using them on a daily basis for a period of time. So why my objective in this is that I want to contextualize knowledge. So I want to really understand the whys of our behaviors, and I do that by connecting three different aspects. So I connect people's practices and values with what experts are telling me in terms of behavioral disciplines, and then what actually the data science disciplines are also telling me in order to analyze and use this data. So I aim to generate knowledge regarding data, tools, and the knowledge that is accessible for these different audiences. So going to, I would like to then share with you two experiences I've had already regarding sharing this kind of thick data. And both are related to a project I'm doing on understanding obesity, understanding how people with obesity actually make their decisions regarding their condition, right? And particularly in the way they use the tools that dietitians are normally giving to them in order to record their dietary behavior. So my aim with this project is to understand, for example, one of the questions that I had to research was like, why do patients with obesity experience they cannot engage in the food self-reporting that are given by the dietitians. So the kind of activities I do are, well, in this case, we interview 10 participants, contextual interviews, very in-depth, with a number of methods that we use in design to sort of capture the values that I'm interested in. And then all these transcripts of this information, we basically, all these recordings of these interviews, we transcribe them, translate them, and then code them with a coding application, and we publish then this data set. So this is one of the examples I have, and I will tell you then later why I think this is relevant and interesting to be published. The second one was in the same project, and the question here was, okay, one, we understood a bit what kind of experiences people have with these self-reporting applications, and we understood that also what kind of negative experiences with it. We wanted to again ask the question, why are they having these negative experiences? And we used a specific food reporting app that is commercially available. And again, we asked 10 participants to use it for 6 weeks. And in this case, we collected 3 different types of data. So not only qualitative data as means of interviews, but we also did some self-reporting quantitative regarding their emotions with this tool. We did, of course, debriefing interviews after the 6 weeks use, and we also had all the data logs from the use of the application. So again, we structure all this information, and here the challenge was to connect all these different data sources, so they became one sort of coherent data set, and we published this in our repository. So to wrap up this quick presentation, I have 2 slides to follow. One is about the challenges that we have gone through by managing this kind of thick data. And well, one of the things is that we have to manage several data users because we're working with also mixed data sets, and also even if it's already qualitative data, we need to involve assistants to help us transcribing, translating, coding, collecting these various sorts of videos, audio materials, and notes. So there's a lot of people involved in here, and it's quite of a challenge to manage all the accesses and so we comply with our own data management plan. Then, of course, there is the training of managing also multiple coders, and this also involves the different versions and multi-platform use of applications. So that's also kind of a challenge we go through when we work on this type of data sets. One important aspect is that we have to work in parallel. If we're doing interviews in Dutch and we want to translate into English, we have to work with these two data sets in parallel, because you miss a lot of information in translations, and this is really about depth knowledge. So it's quite of a thing to have these two things in parallel all the time, but it really gives us the confidence that we're not going to miss too much meaning into it when we translate the original files. And then finally, well, as I said, we are managing large data sets, videos, audio recordings, and all kind of different mixed data, also data logs. So it becomes quite of a challenge at points if it's only comparing when it's only one type of data. Now, of course, we do this because we really feel that there is a expected impact and benefits to the community. And one of them is that thick data is very costly to collect. So the moment that we can share this to others, we're already hopefully helping others to avoid a lot of this effort and then have access to the data itself easily. Secondly is that, well, the transcript itself can be used for completely different disciplines that we are intending from the beginning. For example, linguistics can access to our data sets and see how in different regions in Holland they use certain languages for specific purposes, just to name an example. Again, because it's thick data is so depth, it can also be triangulated to big data that is accessible, like data mining for social media and so. And I think one personal effort that really forces even more to be rigorous in our qualitative studies, because we want to basically provide a good description of metadata possibilities to use it in the future. Well, I think that was what I wanted to share with you today. And if you're interested in this particular project, I am sharing you the link as well of it. Thank you.
Thank you very much, Natalia. That was a very, very interesting speech. We've had a couple of questions posted in the chat. To everybody else, please feel free to post your questions in the chat section and I will post them to Natalia. First question is from Jan. With respect to researchers who do user-centric research, especially for the qualitative data collection activities in the field, any tips for working in the field and data collection with different communities? Simply because sometimes people forget how challenging it is.
Yeah. You mean by different communities, different research communities, disciplines, or different?
I think I just think general different communities, not just research, but
Okay.
communities you're working with.
Yeah. So I think one, and here for me, a data management plan is the key. I mean, in order to define from the beginning different roles, different accesses, different responsibilities. This has for us been the key tool to make sure that, because we're working quite multidisciplinary, I work with dietitians, with designers, with creative industry. So we all have different vocabularies, different ways of working with this data, different expertise, and the way for us has been a data management plan. So that would be my first quick tip for you in that sense.
Thank you. We have another question from Anton Akhmarov. Are the privacy concerns proportionally larger due to the amount of information collected per person?
Yeah.
I would second this as well.
Yeah, well, so for example, the funding scheme of this particular project really pushes us to even publish the raw data, so the audio recordings and the video recordings, and that was for us a big no because of breaching this privacy. So in our training with the students that we work with when transcribing this information, we were very, very strict in making sure that the personal identification of any of these persons will be covered as much as possible, and yeah, that's how we only do the transcriptions and the coding in terms of publishing. But indeed, it's a huge concern for us as well. Yeah.
Yeah. Okay. Thank you. We have another question from Laura Armstrong. In your example about obesity, you collected 6 weeks of data. Is that a typical time frame for thick data collection, or does it vary based on the research question?
Absolutely, it depends, and also, well, as I said, we did not only collect one type of data, but 3 or 4 different type of data sets in these 6 weeks. So that add extra layers. So of course, the longitudinal aspect is one, but then also there is a layer on how many different perspectives you will be capturing this information that you're interested in. So is the research question, is a longitudinal aspect, and is a depth in the type of data sets that you will be collecting, which defines thick data in this case. Yeah. In the end, it's about answering the why question. So it depends on that.
Okay. Thank you. We'll give it a couple more minutes for people to post more questions. I just had a question of my own. Apart from some of the electronic tools you mentioned, do you use any sort of automation tools for your transcription and translations part of your research, or?
We are currently exploring one of them, which of course the name I will have to find it out now because we just started using it. So till now we were using student assistants. Basically, that's our main force, and which works absolutely amazing. I mean, we train them, and then they work with us for a couple of years, and it's fantastic. Lately, we've been exploring a tool that it was hinted by our data steward.
Your data steward is chiming in the chat. It's AmberScript.
No, it's Jeff Love.
Yeah,
Oh, okay.
he's
Sorry,
the data,
he's hinting it. Yes, Jeff is there. Thank you, Jeff. Yes, so AmberScript is the tool that we're using, and actually is quite promising. So now our student assistants are only checking the logs coming out of it and making sure that we're not missing, because of course it's not 100% accurate, but then the load is going down. The effort from their side is going down drastically. So we're very happy with it. It's costly, so that's the only problem. Yeah.
Oh, we have somebody thanking you for the tip, one of our fellow speakers,
Yeah.
Éva Kalmár. Any other questions from the audience? I think for now that's right. Well, we have one more question. A couple more. Did you follow any standard for the encoding or data format?
Well, for the coding, we used basically coding schemes, and we follow a very thorough process of multiple coders and iterations in the coding scheme to get into a set that we are happy with, basically. And then we use atlas.te in this case, so we follow those formats and protocols. If that answers your question. The tags were theirs, I guess. Well, so the way we work with coding schemes is that it evolves what we're looking at the data. So we have a predefined coding scheme, and this one is redefined, and that's the one that in the end we use for all the rest of the data sets. So I'm not sure exactly your question regarding the tags. But I hope I can. Okay, no problem, no problem.
Thank you to Nicholas for that question. And Masha Renaud with the ICT Innovation Department says that they're running the AmberScript pilot. So if anybody else would like to try it, you should contact Masha. I think that's all the questions we have for now. Thank you very much, Natalia, for your presentation. And thank you, everybody, for that. We will now have the next presentation, which is actually a video recording of the presentation. Since Pavlo Bazilinskyy couldn't make it to the event, he kindly provided us with a video of his presentation, along with the presentation itself, which will be shared in the end. So for that, I am going to be sharing the video.
work at streaming faculty, and now I will give a short presentation on. Hello, my name is Pavlo. I work at streaming faculty, and now I will give a short presentation on why I think open science and open data are quite important, and especially in the human factors research, which is my field. So I argue that humans are too complex and too affordable not to practice open science and open data. And I will now describe why I think this is the case. So what we do research with self-driving cars, autonomous vehicles, and we are trying to understand how such vehicles should interact with people outside of the vehicle, for example, pedestrians and cyclists. In this picture you can see a possible example of what could happen in a few years in the future, is that an autonomous car, a red car in the center, is now driving the road, and then you as a pedestrian will now not see the driver because there could be no driver behind the driver's wheel in such a car. So the car will show you a message, will stop, which is designed to replace eye contact, which is what we use today. However, such a situation which involves one driver, one pedestrian is not that common today. So today most situations in traffic do involve multiple people. So in this picture you can see, for example, a pedestrian, a manual car, which could be the car on the right, and then and for example another autonomous car, which could be the car in front of the zebra crossing, which now says the message "don't walk." And such situations are quite a bit more complex. However, today most research involves at least the maximum two people. So one pedestrian, one driver is a good example. But what happens when multiple cars are involved is not really clear. And I understood that there was a lack of research in that field, and actually there was quite a bit of lack of methods to do such research in human factors domain. There was no simulator which could be used to connect multiple people together in an easy enough fashion. So what we did, we initiated the development of our own simulator. And I will now show you how this open source simulator could be used in a small example. So in this video you see that there is me, a pedestrian wearing a motion suit which detects my movements, and also head-mounted displays which show me the world in virtual reality. There is Dr. De Winter, Jos De Winter, and there's also Dr. Dimitra Dodu. And Dimitra is driving a car which is autonomous, and then Joost is driving a manual car, and I'm a pedestrian, as I said. And you can see that Dimitra's car, as an autonomous car, now understood that I, as a pedestrian, could walk, so it showed me a message walk. So it's a bit of a symbiotic interaction in traffic scene. And Joost, as a manual car, however, decided not to give me a chance to cross the zebra on the zebra crossing, so he decided to continue driving, and then there was a situation where there was a conflict. So I was driving, Dimitra's car showed me that I could drive, however the manual car in the world decided not to yield. So this situation, which could potentially be fatal, is something which we look at quite closely. To that end, so we did this simulator, which is now available in GitHub, on GitHub as an open source simulator. And then we also use we outsource the part of development, which I think is a good practice to have in research as well, because we used the skills of a developer quite skilled in the tool which we wanted to use. And then me and my colleagues, we spend more time on management and on the actual science part of the project. Besides the aforementioned simulator, we use a lot of crowdsourcing, which I think is another very good method to use in open science and open data perspectives. So with crowdsourcing you can do quite some robust experiments in a quite limited amount of time. So for example, this shows an experiment which we did with 2,000 people for the total cost of a bit more than $800, and it was done in 2 days. So it went from July 9 until July 11 when it finished. So it's a good example of how you can get quite some strong and statistically powerful data in a limited amount of time, and also in quite a cost-effective fashion. And so we then often, what we do now, we do a lot of research with the couple simulator, Of course, not everything can be done crowdsourced. By crowdsourced, I mean that we upload videos and sounds and images, and then we ask people to do different tasks, which could be done in a simulator or with a laptop. Some things must be done in a lab today, but if the research can be combined in such a way that it can be uploaded online, that's what we prefer, because the data which we get is quite a bit more powerful. And that data gives quite some nice results, I think, so they're worth sharing. And in my work, I always try to share everything. So you can see an example of my 40U page, where I uploaded datasets together with Joost and Dimitra in our papers. So we uploaded all datasets to all our papers online for the public use. Of course, we always anonymize our data, and we always make sure that what we put online can be shared online. And if that's the case, it does go online for us for every single paper which we write, which I think is a very good practice, which I recommend to all of us. And I will go a bit into what challenges I have faced over the last 6 years, which I've spent in TU Delft. So also did my PhD in TU Delft, also in the field of human factors. So traditionally, the human factors research is conducted in a lab with quite small sample sizes. Quite often it's 10 people, 21 years old, all male, all from rich country, and all have quite a good education. However, autonomous cars will be used worldwide, and if anything, they may be the most helpful in the countries which are quite a bit different than, for example, the Netherlands, for example, India, which has 300, 400,000 fatalities on the roads alone every year. And autonomous driving is one of the ways to answer that problem and to reduce the number of people who die. And so I use crowdsourcing from almost the first month of my research in my PhD, and I understood that quite not everyone in academia accepts the idea of using crowdsourcing. Most academics, I think, are not willing so much to go outside of the box, even when evidence is clear and present. In one of my papers, we even managed to replicate a number of quite established and serious studies from back in the day, which dealt with my topic of PhD. And then, but we did it crowdsourced, and we disputed some of the findings by basically just taking a much larger sample sizes of our data. And that is not so accepted. So even though you show the power of data which you have is quite a bit stronger, even if you have the method which is quite replicable online as well, people do not accept it so well from the start. However, now I have like 10 published papers which have used crowdsourcing, and now we do have quite a bit of framework which we developed, which I think works quite well and robustly to filter our data and to have quite a good sample. So now I think we are getting to a point where our colleagues are starting to accept it as well. And reinventing decades-old methods is quite difficult yet rewarding. Also, a good example of crowdsourcing, which is recent, you can see from the pictures in the bottom. So today, autonomous cars, well, in the future maybe, they can show messages with different colors, but they can be green or red. And what does green mean? Does it mean that you can go, for example, across the street if you're a pedestrian, or it means that I will continue driving? It's not very clear. So what we did, we asked people to rank EHMI of a car, EHMI external human machine interface of all colors from a spectrum from red to green, and taken at a certain step. So we had 700 plus colors which we put online, and we did a study in a few days, and it showed that it's not very clear today which color should be used, and today what is now commonly used by industry is the cyan color. It's actually seen in the middle of the spectrum, so that actually sort of gives clarification of why the color is seen as a good option. But so far it's been just intuitive that that color will work. What I learned as well is that preparing data set and making sure it will be ready for publication is difficult and requires quite a bit of effort, but it allows for better structure and gives confidence in results in the publication. So that's why I always try to think of my future data sets from the first days of my project. And sharing data and code promotes cooperation, as potential partners can see what you have. So I have all my data and my code, all my papers on ResearchGate, all my data on FOTI, and all my code on GitHub. And that combination shows quite clearly what I've done, what is my current state of things in my research, and what I plan to do. And I have found partners just by them seeing what we've shared. And whenever research is performed in the public domain, I do think that all of its outcomes should be public by default. So even we're doing science, and I think in science the main final goal of what we do should be the benefit of society and the humanity in general. And I think that's why everything we do, if it's of course publishable and shareable, it should be shared as the public domain. Yeah, and not everything needs to happen in the lab today. So the 21st century now actually offers quite a bit of tools for distributed outsource and crowdsourced science. So you can learn from the IT sector. I do come from the IT background, so I do know some of them from default. Maybe that's why it helped me to learn how to use them as well in academia. But you should learn from other examples, and if you see that some of your research can actually be done in a bit different, distributed and maybe citizen science way, then please go ahead. And all data, yeah, as I said, all data needs to be organized in such a way that it can be shared from day one. It also helps a lot with your own structure of things and with your own organization. And outsourcing and product development should not be afraid of. So we should, it's quite a bit more time and cost effective if you utilize the skills of somebody else who's a professional in a certain tool instead of learning that yourself. So you can spend half a year of your PhD, of your postdoc to learn a certain tool, which is good for you, but in the end of the day, you could have spent the time doing actual science in a way. And thank you for your attention. I'm sorry I couldn't be present real time, so I had to send this video. But if you have any questions, please email me at my email at TU Delft, and probably this presentation can also be shared with you if you find it useful at all. And then we can also grab a coffee, social distance coffee, sometime as well if you're around the campus. Thank you for your attention, and enjoy the rest of your meeting.
Speaker is André Melo. His speech is going to be on Plotocop, studying and improving scientific plotting practices. André, the floor is yours. You can start by sharing your screen. And as earlier, please post your questions for André in the chat.
Yes. Okay. Hope everyone can see my screen.
Yes.
Great. So hi, everyone. I am André. So I'm a PhD student here at TU Delft in the Quantum Tinkerer group in the physics department. And today I'll be talking about a project that I've been doing together with my supervisor, Anton Akhmerov. The project is called Plotocop, and the goal is to study and improve scientific plotting practices. So color maps are important because they allow us to take a bunch of numbers and to visualize them in such a way where we can make sense of our data and find features in our data. That's why they're such an important and ubiquitous tool in scientific publishing, but also in other fields like medical diagnosis. Unfortunately, not all color maps are created equal. And in fact, if you use a bad color map, that can unfortunately create features in your data that are not there, or even hide features that you have in your data. And to show how this works, I'm going to use an example from the paper that I have listed here below. So this is kind of a diagnosis image that the author came up with, which allows to see certain shortcomings of color maps. And if you look at the image in black and white, at the bottom you have just from left to right a linear ramp. And if you look at the top, you have the same linear ramp, but you have a bunch of oscillations as well, sinusoidal oscillations. And the amplitude of this oscillation increases from bottom to top. So The problem is that this is in black and white, and we want to introduce a bunch of colors, right, to have a proper color map. So let's see what it looks like in the popular rainbow color map. We can immediately spot a couple of problems with this image. The first one is that if you look at the top of the picture, you'll see that in areas where the color map has low contrast, the oscillations completely disappear. So in particular, the green and purple-ish regions, the oscillations are nowhere to be seen. The other problem is if we look at the bottom, at the linear region, because we have discontinuities in the lightness profile of this color map, there are regions where fake features are created. So in particular, the yellow region and this bluish region here are brighter than the colors around them. And so your eyes are naturally drawn to these regions, and it appears that there is some sort of feature there, when in reality, if you look at the black and white color map, there's actually no feature there. All right, so this is what things look like in a bad color map. What do they look like in a good color map? So here I'm plotting the same data on the right, but on the default Python color map, or I should say the default matplotlib color map. It's called Viridis, and it's a color map that's been carefully engineered to be perceptually uniform, meaning that basically it has none of the issues of the rainbow color map. So there are no regions where the lightness profile has discontinuities or anything like that. And what we see is that the sign pattern is visible everywhere, and there are no weird artificial features in the linear region. So this is a very important feature of good color maps, is that they are perceptually uniform. Other features that are important for color maps is that they are, first of all, still legible when printed in black and white. So here I'm showing you both color maps in grayscale. And you see that the rainbow color map on the left is pretty much a mess. We really can't see the data well at all. We still have features that are washed out. We can't even tell what is the lowest, where the data has smallest values, where it has higher values. It's really hard to read. On the other hand, Viridis is perfectly legible in black and white. The other important feature is that they're also readable for people with color blindness. So in particular, here on the bottom, I'm showing you the color maps as they would be seen by somebody with trinitopia, which is a type of color blindness. And again, you see that the rainbow color map does quite poorly. Again, we have features that are washed out, and the left and right parts look very similar. Whereas with Viridis, again, we have a perfectly legible color map. So hopefully by now I've convinced you that the choice of color map is very important, but if not, here's an article that I found that shows where they looked at basically the efficiency or the accuracy in heart disease diagnosis as a function of the color map. And they found that doctors using a good color map were 50% more accurate than doctors using rainbow color map. So basically, bad color maps are literally dangerous. So this is kind of the background behind this project. And about a year ago, my advisor and I were thinking about doing something related to this. And we had essentially 3 goals that I'm showing here. The first one is that we wanted to analyze usage of color maps in scientific publications. And we wanted to do it in an automated way. So we really didn't want to have to do this manually. One solution to this is to simply crawl open access preprint servers such as the archive. And this, I think, is where the connection with Open Science comes from, because this project is made much easier by having access to open preprint servers that are also very easily parsable. If we were trying to do this, say, with Elsevier journals or something, it would be much more complicated. Secondly, our second goal was to raise awareness to the importance of using good color maps. And we thought, since much of the scientific community nowadays is on Twitter, why not make it kind of a funny / snarky Twitter bot? And thirdly, we want to make this a project that engages the rest of the community, and we want other people to contribute. And so we decided to make it an open source project. And so let me now show you what Plotocop sort of version 0.1 looks like. It's, as I mentioned, it's a Twitter bot, which you can find at this address here, twitter.com/Plotocop. And currently what it does is it every day automatically crawls the condensed matter section of archive.org. That's our field of physics. And it finds the new papers which use JET, which is sort of the most popular rainbow color map. And then it posts the findings on Twitter. So what papers it detected. And I have a couple of examples here below. So for example, on this day on the left, it found 8 papers out of 90 that use JET. And then, you know, usually it comes with a funny sentence, or at least we find them funny, like there are too many of them or something like that. On the right here, we have another 4 detections and suspected coordinated JET attack. So this is what the bot currently does. And just to give you a little bit more insight into how it works under the hood, basically what the bot does is every day it downloads all of the new papers on archive and extracts all of the images from the PDFs. And essentially an image, each pixel has 3 values, RGB. And so an image is just really a collection of points in this 3-dimensional space, RGB. And accordingly, a color map is really just a curve, a continuous curve in this space. So what we have to do is to take these pixels, project them onto this RGB space, and just see if we have a sufficient number of points close to this color map line. So if we have sufficient points covering this line, we detect JET. To give you some sense of the numbers that we're looking at, on the left here, I've plotted the distribution of detections, and you see that it averages around 4-ish per day, so 4-ish papers per day. But because we have different numbers of papers, or rather the number of papers per day varies quite a lot, I'm also plotting here on the right the distribution of the fraction of papers that contain JET, and you see that that's around 5-ish%. Now, the more interesting statistic to collect would be what percentage of color maps are JET, because there are actually quite a lot of papers that don't have color maps at all. So in the future, we would like to calculate that statistic, but that requires some additional features which we haven't yet implemented. In terms of future plans, we have a lot of possible directions that we'd like to expand the project to. The first one is to detect all color maps, not just JET. So this would allow us to do what I just talked about, to actually figure out what's the percentage of color maps that is JET. We would like to be able to replot figures with good color maps. So for example, if we find something in the paper that uses a rainbow color map, we would like to replot it with VReadies. We'd also like to look at other preprint servers, not just archive. So we'd like to look at bioRxiv, SciArchive, potentially others. And finally, color maps are really just the start of things that we can look at. We'd really like to go beyond that and look, for example, at captions, the amount of information in plots. So you could, for example, define some sort of entropy measure to quantify how much information you have in the color map and do statistics on that. You could look at the typical panels of figures that you have in preprints. There's really all sorts of things that would be cool to study. So that brings me to the end of my talk. I'd just like to mention again that this is an open source project. So if you're interested in contributing, please check out this link here for GitLab. All contributions are welcome, no matter how small. Even if you just want to add more snarky messages for Twitter, that would already be great. And yeah, that's the end of my talk. So thank you very much for your attention.
Thank you very much, André. So do we have any questions for André? In the chat, I just have Jeff Love commenting, "Your Mao creep?" ?
Sorry, what was the question?
Your Mao creep. I think it was just a comment. I don't. It's a bad pun apparently from Jeff. Any other questions for André?
Yeah, can I ask a question?
Sure.
Yeah, so Andreas is a very interesting. I especially like the Twitter bots. I just followed it. One thing that I would like to know is there a way of mapping these potentially like incorrect heat maps to a different color space? So could you take something that has a jet color map and kind of just remap the colors into a more ideal color space? Because that would be cool, right? To have a tweet that has like,
Definitely.
alert, and here's what it could be.
Definitely. So this is something. This is the second feature that I'm suggesting here, and in fact, I have already written code that does this.
Sorry,
it's just
I missed
kind of
this.
production ready. So yeah, this is definitely one of the features that we want to implement next.
Sorry, I missed this point on the slide. You've already
No worries.
You've already beaten me to it. Yeah, thank you.
Thank you. We have Emmy Tsang on the chat saying that really cool, André. There's a similar tool called Jet Fighter working on the bioarchive corpus. So she's put the link to the GitHub repo on the chat. Maybe you'd like to check that out, André. Thank you very much.
That's really cool.
Yeah, thank you. We have a question from Alistair. Are you scraping archive, or is the content already easily available?
So we are currently scraping archive. However, archive actually just released a massive data set of all the preprints that you can download through AWS, I believe. But in order to get the new papers, we have to scrape it, yes. Because this data set is only updated every once in a while, and Plotocop runs daily. So yeah, we have to scrape it at the moment.
Okay.
And how big is that downloaded archive, as it were?
Well, currently we're only looking at the condensed matter section. I'm actually not sure how big that is. I would estimate perhaps something like 300 megabytes, something like that.
All right. Okay, so big but not huge.
Mm-hmm.
Thank you, Alistair. We have a question from Nicholas. Color/heat map became frequent in the news with the COVID virus. Any comments on their usage in the current media?
That's a good question. I mean, you do see a lot of misusage of color maps. You see the rainbow color map all the time, which hopefully by now I've convinced you all is not a good idea. But you also see one thing you also see very frequently. Unfortunately, I don't have an example right here in front of me, but is people using divergent color maps. So color maps that have that are meant for signed data. So for example, something that goes from blue to white to red, that is meant to for example, plot something like deviations from the average value, because it draws attention to the white, right? But people often use it to plot unsigned data, just the continuous data, and that again introduces features that are not actually there. I see that frequently in media, and it's a bit concerning in my opinion, actually.
Thank you, André. That was excellent. We have another question from Leila, one of our fellow data champions. What do you use for the crawling of the preprint server? Python?
Yes, this is all Python.
Okay.
And as I mentioned, if you're interested in the source code, you can check out this link here. Yeah, everything's there.
And as I mentioned earlier, all the presentations will also be shared. You'll all get notifications and emails to where you can get all the presentations. Do we have any other questions for André? If I think for now, that's all the questions we have for now. Thank you very much, André. With that, let's move to our next speaker. She'll be our final speaker, Éva Kalmár. Her topic is Open Science. What do we understand under this term? It's going to be an interactive session. Éva, the floor is yours.
Thank you very much, Santosh. I would like to share my screen. Let's hope it works fine. Now, I hope it's working. You see my screen, right?
Yes.
Yes. Okay, great. The term or the title of the presentation is Open Science, and what do we understand under it? And why did I want to talk about it? First of all, I'm a lecturer and researcher in science communication. I work in the science education and communication department in the communication design for innovation team. And I'm interested in how the different kinds of collaborations are working, and mainly in the dynamics of scientific collaborations, and also how people, scientists, work together with non-scientists also from the field of making decisions. So how decision makers and politicians involved in scientific research, how the different other organizations are involved, and also citizens. When I did my master's studies, I wanted to investigate how scientists work together and use tools together, for example, virtual research environments, and how these are made, how these are designed, who is designing these kind of stuff, who is forcing to use this kind of stuff to researchers, and why they don't use those. So this was the reason I got in contact with Open Science, the term itself, and I figured out that this is actually a great buzzword. So there are vivid discussions about open science, and a lot of people are thinking that they are talking about the same term, but the common denominator of all these kind of discussions is that science needs to open up. A lot of people understand completely different terms under this. So my first idea about this session was that I would like to ask you what your opinion is about open science. What does open science mean to you? So I would like you to go to mentimeter.com and then use the code here above, and then please.
Eva?
Yep.
Sorry to interrupt you. There is like a thick horizontal bar that is seen on your the shared screen. Could you stop sharing and start sharing again? Could you try that out?
Yeah. Is it better? Yep.
Yes, now it's gone. Thank you very much.
Yeah, thank you very much. So please, if you could go to mentimeter.com and then type in the code, which is above here in the screen, and then type in your opinion about open science or your view about open science.
Eva, maybe you'd like to repeat the Mentimeter instructions?
So please go to www.mentimeter.com, and there is a code here, which is 8593800. You should type that code in, and then you can answer the question which is appearing then to you there at mentimeter.com. Yeah, so the first answers are already appearing and coming in. Okay, we already have 12, 14 answers. Oh, that's great. Okay, so by now we have 27 input. Let's start with the beginning. So reproducible research, I see it here. It's something that we should have been doing for decades already. Yeah, this is fair enough. Transparency and sharing, transparency, open source software, sharing code and data. We heard about that today already. Good science, engagement in science with a view towards collaboration now and in the future. Transparent science, accessible, reproducible scientific research that has no societal or financial barriers to access. Okay, let's go a bit further. See what the next ones are. Okay, more transparent, more verifiable science. Let's see what's popping up next. Yes. Open science is about sharing everything, achieving community of knowledge, opening up data, methods, and results that are the results of scientific research and make them accessible to the public. This means not only physically, infrastructure, but also understandably. Achieving community of knowledge, I mentioned that. Open science is sharing knowledge and data with the public, okay? Sharing science done in an open way, transparent process, and results open to all who are interested. Accessible and reproducible, community sharing, transparency coming back again, knowledge accessible to all. Open science stands for the transition to a new, more open and participatory way of conducting, publishing, and evaluating scholarly research. Central to this concept is the goal of increasing cooperation and transparency in all research. Yeah, let's hope it rolls forward in all stages. An instrument in the toolkit of public-private partnering. Okay, I think there is a lot of common points coming back: open source, open data, sharing, and transparency, but there are other perspectives as well. Okay. When I was starting to look around what open science for me can mean and how should I understand it in my research, I came across this book, which is published openly. So it is open source and available freely for everyone. It is written by two German guys, or edited by two German guys, Sönke Barting and Sascha Frisicke, and it is about opening science. And they claim that all the kinds of discussions about open science can be grouped into 5 big categories, which they call different schools. And I would like to go through these kind of different schools: the democratic, pragmatic, infrastructure measurement, and public school, just to explain these with a few words, just to create awareness in this community that what different people understand under open science. And then later on, I would like you to just evaluate these and then think along and then choose what kind of perspectives should we take along in the open science community. Okay, in a nutshell, the public school argues that science needs to be accessible for a wider audience, and because of the social web and Web2 technologies, allow scientists to share their research processes, so not only the results but also the processes with the wider audience. I would like to highlight then 2 major streams in this. First one is then the accessibility of the research process, the production of the research. One of the projects which belong to this category is the citizen science projects. We were already talking about in the last meetings, right? That why do we need this? Of course, that people can also be part of scientific research. It should not be really an elite thing. A normal citizen who is not having a university degree should also be part of scientific research. And this is also visible in the Dutch research agenda. I have to highlight this because this is one of the major points where people also claim that a normal citizen don't have a voice to ask people what to be researched. This is usually decided by funding agencies and researchers themselves, what they find interesting. But citizens also have the right to push through their interests and their agendas. So this is something that I think we are accomplishing really well in the Dutch research agenda. The other one is then the comprehensibility of research results, the product of the research. And that is more related to the science communication field. It's about how research results are published or communicated to the people. This is usually can be found in science research, science outreach projects. The next school, I think, is more identifiable for most of you. This is the democratic school, which is arguing that any research product should be freely available, because then, especially if it is financed from taxpayers' money, then the taxpayers, and especially the scientists, other scientists, should be able to access not only the publications, but also the data, the code, and everything should be really open source to share collaboration, to enhance collaboration and reuse of the data. data. Yeah, most of the argumentations we heard before, I think this is really the part where most of you are aware of. In this book, the authors asked the questions. Well, I said it was from 2013, and by then they already asked the questions that why didn't we reach to a state when open access is everywhere? And they were asking the questions, okay, maybe it's because scientists are reluctant to share, or maybe because there are no real incentives from the scientific institutions to push scientists towards open publications and opening up data and so on? Or is it really then the publishing industry which is not forcing people by publishing then to open up everything? Or are they by chance or by definition against open access? So these are really interesting questions, but I think most of you are aware of it, as I said before. The third big category, which is called then the pragmatic school, is arguing that science is a process that should be optimized as a whole. And they use the analogy of open innovation as much as that could be opened up by intercorporating different stakeholders and also different methods in the innovation process. This is how we should open up science. So they understand under open science completely different issues. And they talk about then processes, how we can really turn closed science into collaborative science, and open access and open publication is just one means for that. And they say that that the different problems that we are dealing with are so complex that we have to really include other disciplines into the research processes, meaning that our scientists are asked or pushed towards multi, inter, and transdisciplinary research. And they also claim that in the research, it would be advisable to include external knowledge as well. So knowledge of different stakeholders like governmental organizations, businesses as well, but also normal citizens, to understand the nature of the complex problems and then work together towards the solution. And technology or science is only one side of the problem. There are usually other issues as well, like economical, environmental, health issues, which are not tackled by only looking at the scientific way. And one of the biggest part of this discussion is how to facilitate these kind of collaborations. And then the technology part of it is then using online collaboration tools. The fourth huge category is the infrastructure school, which is then focusing on open science as a technological challenge. So they actually put this category as an overarching category above all the other four, focusing on the scientific or the technological issues, how to make open science possible, how the different issues, open access and so on, can be achieved. And in the book, there are two major examples are stated. One of them is distributed computing, and the other one is then all kinds of networks and platforms where scientists can work together and socialize, make networks, and also collaborate together. The last one is the measurement school. And they argue that the impact factor is a completely outdated and decisive measure of a researcher's reputation and career. And they say that it is measuring only a journal and not even a publication, but the journal where it was published. So it is more, it is not really representing what the article is publishing or mentioning itself, not qualifying the research itself, but the marketing process, how the article landed in that journal. And they also claim that there are lots of problems with the peer review system, that the impact is linked to the journal, not the article. And they claim that we are at the 21st century and there are already other ways of publishing. And this is not really figured out how to measure the impact of these new publishing formats, and also how to measure the impact of science outreach. For example, if a scientist is giving a talk at a science museum, How does that impact calculated? Can you take that into account? If you participate in a project as an expert, how can you take that into your portfolio? This is also something important, and the social impact of these kind of interactions are huge, but not taken into account in academic profiling. So they are suggesting completely new ways of measurements, and altmetrics is one of them. Calculating then the online presence of scientists, where do they actually post the calculating the blog posts, the mainstream news stories where the scientists are mentioned, and so on. And also social media shares, if we were talking about then Twitter. Okay, so these are then the different perspectives, how you can look at open science and where the current discussions are going. I wanted to ask you if I miss an important aspect, if these guys writing these books, leaving out something that you would like to be added into that. So if you have an idea, and if you still have the Mentimeter site open, you can just type in, or in the chat, it is also possible. What do you miss here? I see education popping up. Great, yeah, that's an important point, right? Reproducibility, indeed. That's also in an important one. Fair points. Combining all these schools, yeah, that's a good idea. Understanding human behavior, open review. Another point for combination of all approaches. Funding, rewards and recognition. Yeah, I think I see clearly that it made you think about then different perspectives and different aspects of open science and the related things. Altmetrics, like social media, can be easily manipulated. Fair point. Copyright versus open licenses. Impact of privacy issues. Now, really good points. Assessing open science. Effectively, quality. Yeah, what is then the quality of these? Commercial usage of scientific results. Indeed, where does this go to? Yeah, in impact studies, of course. Okay. I see by now, yeah, there is one more popping up. I'm curious, where does it end? Quality. Yeah. Okay, thanks for your input. This is really interesting. I wanted you to kind of rank which aspect would you like to be represented in the TU Delft Open Science Framework or in this community? Which one do you think was to get the most emphasis from out of those? And of course, we mentioned others as the sixth aspect. I would also take into account these comments, what you just mentioned. You said that, okay, these are really important, like education and so on, and all these aspects. So please vote for those which one you would like to really be seen in our portfolio as the TU Delft Open Science community. Oh, it's really interesting to see how there's different rating is going. Yeah, that's a really cool feature of Mentimeter. I like that. So far, the democratic part, the open access and open data is at the first place. And then collaboration is at the second. And also then the different measurements and impact studies are at the third. Okay, let's see if it's changing. It looks like infrastructure is coming up. like the overarching part. Yeah, indeed, that's an important one for sure. Okay, so far 27 people voted. Okay, I would say that we take this as the final result for this voting. So first one, or no, there is one more coming, but not changing the picture. So democratic one is at the first place, then pragmatic about collaboration is second, third, infrastructure technology, and then almost at the same level as measurement school with impacts and metrics. The fifth one is about citizen science projects and outreach, and the others are also important. Okay, thank you very much for voting. Now I would like you to think about that. How should we tackle these issues? So there are different aspects as well, cover every aspect as you suggested as well, to merge everything into our portfolio. Choose, let's say, the top 3, or ask people to join in different work groups where they are dedicated to different perspectives. What would you like to see in the community? Okay, as far as I see, it's almost at the same level now. The different work groups are, it seems that this is the top choice, but yeah, maybe it will change. Yeah, cover every aspect or more of the aspects, and then ask people to join work groups dedicated to different perspectives. So then in this way, we can of course then cover every aspect, so it is not really contradictory to each other. So I think that the majority of the people would like to cover everything as possible and then work on different perspectives as individuals or teams. It would be nice then to discuss then in different ways in the question and answer forms, how could we do this? And I think that would be advisable to ask those people who are at the management of this team, the Open Science Community, just to join giving the answers to these kind of questions. So please ask your questions now in the Q&A session, and then we can join in the discussion.
Thank you very much, Éva. We did have
Santosh, I don't hear you.
Looks like Santosh is frozen.
I think so too. Do you have any questions actually to Éva? And if so, can you please put it in the chat? Don't hear anything at all, or just Santosh?
can you hear me?
Yes.
Now we can. Yeah, you're back.
Sorry about that. Not sure what happened. So I was just repeating Anka's question. I don't know if Éva had a chance to answer that.
Anka's question, can we also combine all of these schools? You mean that one?
Yeah.
Yeah, I think in this way it is possible that, of course, we take these into the portfolio of the Open Science Community, and then we figure out who's willing to work on which aspect. I think that would be a good approach.
Okay. This question from Alistair. Are any of the schools in opposition to one another?
I would say that some people are, but not the schools themselves, not as a big whole, but some would say that, yeah, this is much more important than your topic. Yeah, it can happen as well.
I asked that question, Éva, because in my mind they're all overlapping and quite similar.
Yeah.
And only because this morning I came across an article that a colleague from Australia tweeted, Danny Kingsley, and saying that the community that was interested in open science was a different community that was interested in reproducible science. And for me, this was amazing, because I always thought that reproducible science was part of science. But this is, I'll just put actually the article, I've just popped it into the chat box there. It might be interesting for people to look at.
Oh,
but
nice.
it's really saying that the kind of the people who are engaging in reproducibility aren't necessarily the people who are engaging in open science. And to me, that's very strange. But it does show that perhaps in certain things, these are different contexts and different groups, that it might not be so easy to bring them all together as it kind of appears by thinking they're just overlapping.
Yeah, thank you very much, Alistair. I think it's a really interesting thought, and I think that the different schools represent also then kinds of limitations to their approaches. So I think they are not really looking to solve the other schools' perspectives as well. So that can be also something that, okay, they are not interested in opening up data while they are working on reproducibility, which is weird, because if they are open, then of course they are easy to reproduce, but yeah.
I mean, but I think that's also interesting, because it can be useful to think about what are the limits of open science. So what can open science not help with, and where it stops at open science becoming something idealistic and utopian, to perhaps recognize there's certain things that we don't want to be open, and certain things where open science can't solve the problem. Again, that's more a discussion point, more than something that we can easily finish off and solve now.
Yeah, indeed. There are lots of questions coming up.
We have a question from Jerry. Do you find there is competition between these schools? I think it's similar to the opposition, but maybe is there a specific type of competition?
Yeah, just what I mentioned, then putting then the priorities on the list. There is a competition. Which one is the first issue to solve? And I think that's in that way, there is a competition instead of synergy or collaboration between these schools. And I think the problems behind these issues are more systematic, and there is no priority in solving the first issue or the second issue, but there should be more like a systematic approach in tackling these questions. How could that be solved, and then helping science in general?
Okay. We have another question from Jose, tacking on the previous point. Aren't these narratives just different ways of doing politics in science in certain contexts, because they overlap a lot, but the framing is different? This was in connection to the opposition of the different schools question.
Yeah, I think so as well. But yeah, I think that they also tackle different stakeholders. So then involving different stakeholders in the scientific research process is then focusing in completely in one framing, of course, and then solving issues. And yeah, I think these are all different interesting aspects, but the solutions they use to answer the questions, or they are focusing on the different solutions, is completely different.
I think there are a lot more questions that are coming up, but since we are running out of time, I think hopefully Emmy will have time after the closing of the event during the drinks. You can ask more questions to her. And of course, they're all researchers at TU Delft. I'm sure they'll be very interested to receive your questions. For now, let's move to the final announcements. I request Alistair Dunning to make the final announcements.
Thank you very much, Santosh. I'm Alistair Dunning. I'm Head of Research Services at the TU Delft Library. And I'm just introducing the final two people that will be speaking today. We will have the last word we will give to Rob Mudde, our Vice-Rector Magnificus, in a couple of moments. But first, I would like to ask my new colleague to the Open Science team at the library, Emmy Tsang, who will be the community manager, just to introduce herself to everyone, because she's going to be basically taking up all the work that we've discussed today.
Thanks, Alistair. Thanks, everyone. Hope you can hear me. Yeah, thanks for the introduction and thanks for the great event. I'm really excited to be part of this community. Yeah, my name is Emmy. I am for 2 days now the Community Engagement Manager for the Open Science Program at TU Delft. Previously, I had a research background in neuroscience, did my PhD, finished it 4 years ago. I got asked, I got sent, it's funny, I'm just telling a little bit of a story here. I got sent an email sort of 2 days ago by my previous institute asking me to confirm that I've not published anything from my PhD over the last 4 years. And that sort of made me reflect on my research career, having done sort of, I don't know, having been spending time in the lab doing wet lab since I was 18 for almost every single year, and then did a master and PhD. I've actually not had my name on a single publication, and I'm the I guess the poster child for an academic failure there. But what I wanted to say is, you know, a lot of the issues that you mentioned, I think that was why I started doing sort of open science community work and really being passionate about the topic, was because of this. You know, I mean, I got paid for doing this work, but the work that I did was never published. And so there's a lot of issues here to do with, you know, how research is communicated, how research is shared, how folks, researchers and everyone participating in research, not just researchers, are recognized and rewarded for their work. And yeah, so I'm really excited to be working with, to have the opportunity to work with your researchers and everyone else, Open Science Project teams, to make a change to this situation. Yeah, so previous to here, I was working for eLife Sciences Publications, which is a nonprofit that publishes an open access journal in life sciences. So this is sort of the expertise, let's say, that I bring in terms of knowledge in publishing and community engagement. But I really have a lot to learn about your work, about TU Delft, about the research culture here, and I look forward to working with everyone to create your own open science journey. Thanks.
Thank you very much, Emmy. And over the course of the next few months, Emmy will be in touch with lots of you to take forward many of the ideas we've discussed. So, and now I would like to finish off today's event by handing over to our Vice-Rector, Rob Mudde, who will give some closing remarks. Rob.
Yeah, thanks very much, Alistair. Dear colleagues, first of all, I think we owe a big thanks to the organizers of this meeting. I think it was another great example of what a community can do. Thanks to the four speakers, Natalia, Pablo, André, and Eva, if I wrote that down correctly. What I like about it is apart from the topic open science, which is really important to the university, is that this community manages to be across the entire university. It is not that often that colleagues from various backgrounds and different faculties talk about this stuff. And I think that's great that we do so. I noticed in the chat that people got inspired by, what was it, AmberScript, what André told us about how you can work with color coding and how they can be really misleading. It's just great to have talks about. Unfortunately, we couldn't respond to Pablo, but I'm pretty sure that he would have drawn also quite a few questions, and Eva made us react whether we liked it or not. So that's a clever way of getting us all engaged. I marked a few things, so if you don't see me staring at you, but there's paperwork in front of me that I try to scribble on what I find important as takeaways here. The topic in itself, as I said, is important, and you see that there's various aspects. And I voted that we should work on all aspects for a number of reasons. I find them all important,
but equally to me matters that the researcher doesn't exist. We have several hundreds, a couple of thousands if you include all the PhD students, and they're all individuals. They have all their different takes and all their different weighing of what is important, and we should treasure that. So indeed, collectively work on everything, and then we'll progress like the way that we do. One of the things that that I wrote in, you couldn't of course see because we didn't put our names on, that we also have to work on has to do with rewards and recognitions, the phrase that I put in. And the reason why I think that's a crucial step that we should not forget in all the work that we do has to do with at the early stage when we talked about open science, and I wasn't in the board, it's about 8 years ago, I guess 7, I'm not sure anymore. But we started talking to one another in the department that I was just researcher in. And one of the ideas was, yeah, we should have everything open, including software. And then one of my colleagues who works in the field of having very specific softwares, I responded, are you mad? Are you out of your mind? I'm not going to hand over my great software that I worked 10 years on and pass it on to others, and then they can have their successes with it. And I think in retrospect, what we all meant by doing so is that the problem was not that he handed the software to somebody else. The problem was that he felt that the others would then go away with the prize. So it has to do enormously with reward and recognition. He probably felt that he would not get any rewards in his scientific career. But if you look at it, he made it possible for tens of others if he would have done so. And I'm not blaming, that's not the point. But if we would have had a system where he would have been open, handed out his great software, we would have progressed much faster, and he should have had the rewards and recognition. I don't know how to do that. It's because it's easier said than done, as we're also all trapped in that kind of rat race that science has become over the last decades. But taking these things into consideration while working on our movement towards open, understanding that, if I try to explain it with another example, if you decide to buy your soccer team, I guess nobody of you would, but some people do. If you would buy a soccer team and you would select the best soccer players based on their ability to score, I guarantee you that you will lose all matches because your goalkeeper would be terrible. And there you see that if you don't understand that science in itself is much wider than scoring goals, it's important, but it's much wider, then we're not going to change this. And I think we can. I think we collectively can and try and understand why some things are important to certain researchers and make it as wide and open as we can and recognize and try and find rewarding, try and find measures, not only impact factors, that is the one that scores, but there is also the goalkeeper and so on. And I think that with this movement that we now started here, started with in the last meeting with the Data Champions community, expanded it to Open Science Community in Delft, and making that circle within Delft and outside Delft bigger. And we're trying to work on that in the Netherlands. Would really have in it that we all benefit from it in a more pleasant atmosphere, in a much easier way to cooperate, and in the joy of bringing science with all that it has, including the education that we do, 2 or 3 steps further. And I'm pretty happy to see so many of you hanging around in this meeting. Thanks all. Thanks for the organizers again, and I hope to see you in the next meeting.
Thank you very much, Rob. That was very good to have those comments. In the chat box, there's been suggestions that we need to use the analogy about the football team a lot more. I suggested that we should copyright it or trademark it and make some money out of it. Everybody, thank you very much for attending our Open Science Community Day. There's a lot more to come, and the program is really just beginning. The program will go on to 2024, and Open Science will go on even longer. And we very much hope that you will be able to play a part in the community and the various aspects of the project that we have coming up in the future. And Emmy will be one of the key points, but also all the other staff members who are engaged in these projects will also be in touch to take the communities forward. So thank you very much. Thank you very much to the organizers, and I look forward to seeing you all in the future. Cheerio.
Bye-bye.
Thank you very much, Alistair, and thank you everybody for joining our launch event. Now we will have our virtual drinks reception and networking. So feel free to hang around, and the conversation will continue in a much more informal setting. We'll see about if we want to have maybe breakout rooms for groups of people if they would like, but otherwise we are going to have a common virtual drinks reception and networking now. Thank you again, everybody.